In this video, we will discuss the ultrasonic pulse velocity testing method and how it can help engineers in quality control of new construction as well as the inspection of existing concrete structures. Ultrasonic pulse velocity is a common non-destructive test for evaluating integrity and quality of concrete materials and structures. The test has been widely accepted in testing concrete materials. It has also been standardized as the standard test method for pulse velocity through concrete. The test can be used for a variety of applications. Applications for engineers involved in the inspection and evaluation include assessing the quality variation of concrete, assessing the thickness variation, measurement of surface crack depth, and establishing the homogeneity of concrete. Most commercial UPV devices include a device for data acquisition, display, and interpretation, as well as a pair of transducers. The test is completed in just a few steps. A transmitting transducer sends a wave inside concrete, and the receiving transducer, at distance L, receives the pulse through the concrete at another point. The transit time of ultrasonic pulse is then measured by the apparatus. By knowing the distance L and the transit time t, one will be able to measure the pulse velocity in the concrete using the equation V equals L over t. So in summary, the basic idea behind the pulse velocity method is that the velocity of a pulse depends on the quality of the concrete. In general, the higher the velocity, the higher the quality of concrete. Conversely, a low velocity often yields low quality concrete with the presence of anomalies and deficiencies. So as you can see, by using this test, you can use the velocity calculated in order to assess the quality of concrete. The most accurate configuration is the direct transmission, mainly because the maximum energy of pulse is transmitted and received. However, this configuration is mainly used to test lab samples or concrete cores and cannot be used in the field for elements with one-side access only. If two sides of the element is accessible, then a semi-direct transmission configuration can be used. This configuration can also be used to test lab samples and concrete cores. When the concrete surface you are testing has one side access only, then an indirect or surface configuration can be used. This means that both transmitting and receiving transducers are placed on one side of the element. This is the least desired configuration and is also known to be prone to errors. Certain parameters can affect the UPV test results, including aggregate size, the quality of test surface and transducer contacts, cement type, concrete age, and presence of reinforcement. Special care should be taken in order to minimize these impacts on test results. To learn more about F'(C) and the non-destructive testing solutions that we offer, visit our website at f'c.com.